In the last lecture, we discussed about the optical properties of nanomaterials and also the interaction of light with matter. So in this lecture, we will discuss about the synthetic routes of nanomaterials. We will discuss the synthetic routes of nanomaterials. Okay. So there are two synthetic routes, that is top down and bottom up approaches. Top down and bottom up approaches. Okay. So classification techniques of synthesis of nanomaterials. So there are these are two general approaches for the synthesis of nanomaterials, that is top down approach and bottom up approach. So what is top down approach? So basically top down approach involves the breaking down of the bulk material. Top down approach involves the breaking down of the bulk material into nanoscale material by various means. Okay, so what is top down approach? The top-down approach involves the breaking down of the bulk material into the nanoscale material by various means. Okay, so there are so many methods in the top-down approach. So, okay, so these methods are these methods includes the lithography, ball milling, attrition, quenching, etc. Okay, so these are the methods used in the top-down approach. So basically top-down approach means what? Breaking down the bulk material into the nanoscale material by various means by using these methods. These methods are important. Okay, so this is basically about the top-down method for the synthesis of nanoparticles. Now we will see the bottom-up method. So in the bottom up method, so this is the bottom up method. In this bottom up approach involves buildup of material from the bottom, that is atom by atom, molecule by molecule, or cluster by cluster. In this method involves the material from the bottom. So this diagram explains the top down and bottom up approaches, how these methods are useful. Okay, so in the top down approach we discuss the what involves the breaking down of the bulk material. So here this is the bulk material. Okay, so in top down approach this is a bulk material. We breaking down the bulk material into nanoscale, so by various methods. Okay, that is like coating, lithography, these techniques breaking down this bulk material and forms into powder. Then next step is नॅनोमेटल. म्हणजे काय होतं की बल्क मटेरियलचं ब्रेकिंग डाऊन करून आपण नॅनो पार्टिकल सिम्पली प्रिपेअर करू शकतो इन टॉप डाऊन अप्रोच. And in bottom up approach the atoms or involves the buildup of material. So in bottom up approach involves the buildup of materials. म्हणजे buildup करायचं atoms to atoms, molecules to molecules, and cluster to cluster, then build up to form a nanomaterial. So this is a bottom up approach. Top down approach means what? Breaking down the bulk material into smaller particles, that is nanoparticles. And bottom up approach means what? Build up of atoms or molecules. This is known as top down approach and bottom up approach. Okay, so now we discuss about the synthesis methods of nanoparticles. So there are various synthetic methods in the nanoparticles. So first is Sol-Gel method, second is chemical reduction method, and third is precipitation method, chemical vapor deposition method, also called as CVD. Then next is hydrothermal method, and last is electrodeposition method. So these are the methods used for preparation of nanoparticles in a large scale. So we will discuss these methods one by one. So firstly we will discuss the chemical reduction method. So in this method, this is very popular method. So in this chemical reduction method, so nanoparticles of different metals can be synthesized by the chemical reduction method. So various metals can be synthesized by this process. Metal nanoparticles can be synthesized by this process, that is chemical reduction process or chemical reduction method. So in this method, metal precursor solution such as metal salt solution is treated with a suitable reducing agent and appropriate stabilizing agents are added. After further treatment and drying, nanoparticles of metals are found. So in the chemical reduction method, metal precursor solution such as metal salt solution is treated with suitable reducing agent. So metal and precursor solution as a metal salt. Metal precursor solution such as a metal salt solution is treated with a suitable reducing agent and appropriate stabilizing agents are added. So this is a very long process. In your syllabus, this is a short term introduction of this process. So after further treatment, drying and nanoparticles of metals are formed. So main example of this method is synthesis of silver nanoparticles by chemical process. So silver nanoparticles is the example for this process. Silver nanoparticles are prepared by this chemical reduction method. So this is the basic information regarding to this chemical reduction methods. Now we move forward to the another method, that is a precipitation method. So in precipitation method, earlier we discussed about the chemical reduction method. The best example of chemical reduction method is the example of silver nanoparticles by chemical reduction method. Preparation or synthesis of silver nanoparticles by chemical reduction method. Okay, so here silver nitrate solution is taken as a precursor, metal precursor, and hydrogen hydrate as a reducing agent, and sodium dodecyl sulfate SDS as a and citrate of sodium are used as a stabilizing agent. So this is a process to how to make the nanoparticles, that is silver nanoparticles. So this is the basic information or basic process regarding to the preparation of nanoparticles with the help of chemical reduction method. Okay, so example is what? Silver nanoparticles using the silver nitrate solution. Now next we will discuss about the precipitation method. So what is precipitation method? So this is one of the oldest methods for the preparation or synthesis of nanoparticles. So this is one of the oldest methods for the preparation or synthesis of nanoparticles in the precipitation from solution. Okay, here you can see that it is the oldest method for preparation or synthesis of nanoparticles is the precipitation of solutions. So in this reaction, in the precipitation reaction, the metal precursors are dissolved in ordinary solvents such as water, and a precipitating agent is added to form an insoluble solid that is precipitated. So in this method, in this precipitation reaction, metal precursors are dissolved in ordinary solvents such as water. So here solvent used is water. This is important. That is ordinary solvents such as water, and precipitation agent is added to form an insoluble solid. So what is, you already know what is precipitate, that is insoluble solid that is precipitate. Okay, so in this method precipitation reaction, the metal precursors are dissolved in ordinary solvent. तर मेटल प्रिकर्सर हा ऑर्डिनरी सॉल्व्हेंट मध्ये डिझॉल्व केला जातो आणि त्या ठिकाणी प्रेसिपिटेशन फॉर्मेशन होतं, त्यालाच आपण प्रेसिपिटेशन मेथड असं म्हणतो. तर या ठिकाणी याचे एक्झाम्पल आहे झिंक ऑक्साइड ZnO नॅनो पार्टिकल्स कॅन बी सिंथेसाइज्ड बाय precipitation method by using zinc nitrate and KOH as a precursors. So these are the important precursors used for the preparation of zinc oxide nanoparticles. So zinc nitrate and KOH as a precursors. These are precursor used for zinc zinc nitrate and KOH. Okay. So this is about the precipitation method. So what is precursor? The inner zinc oxide, the inner formation of nanoparticles of zinc oxide. We simultaneously using the word precursor. So what is precursor? So in chemistry, a precursor is a compound that participates in a chemical reaction that produces another compound. Okay, so precursor means what? A compound participate in a chemical reaction that produces another compound. This is known as precursor. So here in zinc oxide nanoparticles, zinc nitrate and KOH is used as a precursors. Okay. So this is basic information regarding to the precursors. So this is explanation for the precipitation method. So we already seen two methods, that is chemical reduction method and precipitation method. Now we discuss the another method, that is chemical vapor method. Okay. So what is chemical vapor deposition method? So in this method, it is also called as CVD. Here we can see that chemical vapor deposition method, also called as CVD. It is known as CVD. Okay. So in chemical vapor deposition method, in this method, precursor is heated in the gas form at high temperature and vapor phase constituents are introduced into the reaction chamber. These gases are absorbed on heated surface and they deposited on the surface of substance, or due to the reaction with the hot surface forms a thin layer of surface. Okay, so this method explained that in this method the precursor is heated in the gas form at high temperature. So here in the diagram you can see that the reaction chamber is there, exhaust gas out, substrate, heat surface and gas vapor in. So in this method, the precursor is heated. That is the substance we used is heated and we pass the vapors phase. We pass the vapors in this reaction chamber. Then the reaction of substrate and the vapors can lead to the formation of nanoparticles. So this is the information regarding to the chemical vapor deposition method. So this is reaction chamber substrate. Okay. So this is basic information regarding to the chemical vapor deposition method. So in this you have to only, for your exam point of view, you have to only remember the no need of theory, but you have to only remember the which precursor is used, what is the importance of this method, why this method is used. These are the basic terms you have to remember. So now we will discuss the next method, that is hydrothermal method. That is, we will discuss the next method, that is hydrothermal method. So in this hydrothermal method, so what is hydrothermal method for the preparation of nanoparticles? So this is also the one of the most commonly used method for the preparation of nanoparticles. So these all processes are used for the preparation of nanoparticles. These all processes are commonly used processes. So in the hydrothermal method is one of the most commonly used method for preparation of nanoparticles. Okay, this is one of the most commonly used method. So in this method is nothing but a synthesis of a substance via chemical reaction in a sealed and heated solution above abundant temperature and pressure. So this reaction is nothing but synthesis of substance via chemical reaction in a sealed and heated solution above abundant temperature and pressure. So this reaction is basically Synthesis of substance via chemical reaction in a sealed and heated solution above the ambient temperature and pressure. So the temperature should be less in this reaction, hydrothermal reaction. The main important thing is that the temperature should be less than 300 degrees Celsius. So we using the chemical reaction here in a sealed and heated solution. So the temperature of the sealed and heated solution should be less than 300 degrees Celsius. Okay, and this reaction is carried out in aqueous solution, so it is also called as hydrothermal or hydro plus thermal method. That is, hydro means water, that is aqueous solution, plus thermal. Okay, this is also called, this is known as, why this is called as hydrothermal method, that is hydro plus thermal energy we use, that is therefore this is known as hydrothermal method. So next method is electro. So there is another method, this you already know this method, that is electro deposition method. So these are the some methods we discussed for the preparation of nanoparticles. That is, first we discussed today is that top down and bottom up approaches. So what is